Hey everybody, Mr. Wells back here with part 2 of your Data A Rational and Radical Test Review 2021. Again, the document looks like this. You should probably already have a copy of it, or you could pick it up on the Google Classroom. If this is a year in the future and you happen to be watching this video, feel free to just pause the video and copy down any problems if you don't already have a copy of this review. But again, Data A Rational and Radical Test Review part 2. If you haven't seen part 1, feel free to go back and check it out. Okay. So one of the first things that we were doing after we had something that looked like this, where I'm like, okay, we could graph rationals, we could add rationals, we could multiply rationals, divide rationals, or solve rational equations. And they all look so similar, but each one of those things are slightly different. So we just have to be really careful when we go ahead and do these. Okay, so here we go. This first one, I have x squared plus x minus 30 over x minus 5 equals 11. And it says, go ahead and check your answer when you're done. So if I'm solving this equation, there's values of x that will probably make this true. I'm going to try and figure out what it is that I need, but I want to find out what this is made up of. So factoring is really essential on this. So I can see that factors of 30 are 6 and 5, and 6 and 5 differ by 1. So this is x plus 6 and x minus 5. Therefore, that x minus 5 and that x minus 5 kill each other off. And I get x plus 6 equals 11. Now, when I subtract the 6 from both sides, I get x equals 5. I'm like, yay, check mark, smiley face, it all works. Or does it? So when I plug the 5 back into my original problem, you can see that I have 5 minus 5, and that's division by 0, and you know that that is undefined. Can't do division by 0. So I know that in this case, x equals 5 is an extraneous solution. Okay? And I'm going to do the next one right now. Hopefully on this, we can see this. Factoring again on this bottom one. This is factors of 28 that differ by 3, 4, and 7. Okay, so x minus 7, x plus 4. And you can see that if I'm adding fractions, I have to have the same denominator. And this has a denominator of x minus 7. This has a product of denominators of x minus 7 and x plus 4. So what I really need to do is, on this first fraction, I need to get another x plus 4 in there. So I'm going to multiply x plus 4 on the top and x plus 4 on the bottom, which really means that we're just multiplying by 1, changing the way it looks. So now, I'm going to write this out a little longer than what I normally would, but hopefully this will help for you. So on the top of this first fraction, plus, and then this next fraction, I'm just going to copy that down over x squared minus 3x minus 28. So this first fraction right here, x times x is x squared. Outside is 6x, inside is 4x, so that's plus 10x. And then 4 times 6 is plus 24. And then its denominator is again x squared minus 3x minus 28. And you could leave both of those factored, or you can put them together. It really doesn't matter to me. Equals, so new numerator, x squared. 10x minus 12x is minus 2x. And then 24 minus 59 looks like that's 35. So minus 35. Over, and I'm thinking because of the 35, I might want to write this out as two separate ones. So again, you can leave it together or you can factor it out. The reason I do that, because 35 has factors of 7 and 5, right? So x minus 7 and x plus 5. And then I'm like, oh, look at that. That x minus 7 kills that x minus 7. And my final answer on this one is x plus 5 over x plus 4. And as you well know, I also probably should state that x cannot equal in the two places that would give us a 0. So x can't equal -4, or positive 7. Okay, the negative 4 is obvious as 0 for this one, but the 7 that was removed from that is also an issue. Okay, here we go. Subtract 2x squared minus 48 and x squared minus 16 minus x plus 6 over x plus 4. So same thing again, I need to get these to be common denominators. So I'm hoping that you know that x squared minus 16 is x plus 4 and x minus 4. So I'm going to go ahead and deal with that. And this is subtraction, right? So I also got an x plus 4 there. So I'm going to have 2x squared minus 48. And then I'm going to subtract whatever this fraction is. So x squared plus 10x plus 24. And again, that's a subtraction of everything here. So my new, and I'm just copying along this, right, x squared minus 16. This becomes an x squared minus 16, just like it was on the last question. So my new fraction, 2x squared minus x squared is x squared. I got a negative, right, a negative 10x. And then I got a minus 48 minus 24. So 48, negative 48 and a negative 24, 60, 72, negative 72. Okay? So in this case, I'm still over x squared minus 16. So I know that 72's factors are 8 and 9, but those don't differ by 10. So I can cut this one in half and double this one. So 4 and 18 is also there. 6 and 12 is also there. And I'm thinking, I don't know if there's anything that differs by 10. So if I wanted to, and this was on the calculator, I could go ahead and grab my calculator really quick, and I could check it out this way. Go ahead and clear. And I'm just going to check my equation. Maybe I missed some factors. So x squared, right, there's my squared, x squared minus 10x minus 72. And I go ahead and graph that. And you can see that it obviously goes through, and it doesn't go through an actual tick mark. So that means if it goes through between tick marks, then it's not nicely factorable. It still could be if there was a coefficient on the x squared, but that makes it pretty obvious. That's not factorable. So my final answer is this, knowing that x cannot equal 4 or negative 4. Okay? Here we go. Graph this one. We've been doing several of these. Let me get some colored pens here. Make sure that we're okay on this. There's a red one that works. So graph this, including all asymptotes, intercepts, and everything else. So I know that this is a rational function because of the fact that the x is in the denominator. I know that this 0 in that denominator makes a vertical asymptote. So I'm going to go to 4. I'm going to go, hey, that's a vertical asymptote, and I think I'm going to throw that red pen away. See if I make it all the way over there. 30-foot toss right into the garbage over there, so yay. So I'm going to make this a little darker. There is my vertical asymptote. My vertical asymptote again comes from the denominator. My horizontal asymptote comes from the numerator, or that number that's out there is the vertical shifter. So these are my two new asymptotes. Negative means that the graph's actually going to go into the second and fourth quadrants, so they're going to be in these diagonals. So what I'm going to do is check right now some values that I know will work. So here we go. Let me do a little t-table, x and y. And I'm going to do the x one first. So plug 0 in for x. So I get negative 21 divided by negative 4, and then plus 2. So for those of you who are not comfortable doing that in your head, negative 21 divided by negative 4, enter, plus 2, enter. So I got 7.25. Okay, so 0 and 7.25. Now before I just plot that, I'm going to look at my picture and I'm going to go, hey, Does that make sense? So that blue dot is right there. Well, if it touches right there, that means that this one's probably going to look something like this. And I'm like, that's a long ways away from the asymptote. And then I remember what Mr. Bell said, or what I said, that that's a 21. And the bigger the number, the further away this thing has to be. It doesn't have to be perfect. I just want you to at least have a couple of key points. Now over here, you're going to see that it also has an x-intercept. Well, if these things are mirror images, the other one should be something just like this, which means that its intercept is going to be someplace probably beyond 7. But I'm going to check it out. Go ahead and do the math. So I'm going to plug 0 in for y. So that gives me this equation, 0 equals negative 21 over x minus 4 plus 2. When I solve that equation for x, my first step is to move that to the other side. So I get negative 2 equals negative 21 over x minus 4. Cross multiply, right? Negative 2x plus 8 equals negative 21. Subtract 8. Oh, move that camera a little bit. Negative 2x equals negative 29. Divide by negative 2, divide by negative 2, and x equals, what, 14.5? It's going to do 13, doing the math right, 14.5. Negative over negative, and there we go. So 14.5. So, just like I said on my picture, this is 7, 8, 9, 10, 11. It was going to hit someplace over in here. It actually hits a little bit wider than I even had it at 14.5. Okay, hopefully that's good for those ones, and that you're feeling more and more comfortable on that stuff. I'm going to go ahead and flip the page. This one right here, I got 2x minus 6 over x squared minus 4x plus 3. And I want to graph this thing. So step number 1, I'm going to factor the top like a dentist and see that that's 2 times x minus 3. Remembering, if you have issues with your factoring, I have videos that are just on factoring, and you can watch those. Parentheses, x minus 3, x minus 1 equals. That x minus 3 kills that x minus 3. And I'm left with 2 over x minus 1. And there's nothing left, so if you want to call that plus 0, you can call that plus 0. So in terms of some of our stuff, vertical asymptote is going to be at x equals 1 from that. Horizontal asymptote is going to be at y equals 0 from that. X-intercept is going to be none because of the fact that the horizontal asymptote is 0, or there's nothing left up in the numerator spot. Y-intercept, we can get that from the very first part of it. Plug 0 in for all the x's, and I'm left with negative 6 over 3. So that's negative 2. And holes in my function, I'm going to go ahead and set up a little bit more so you can see that. Holes, you can see that there's a factor upstairs and downstairs that are the same, and that means I'm going to have a hole at x is equal to positive 3. So now I'm going to go ahead and plot all of these things. So vertical asymptote at x equals 1, right? Horizontal asymptote at y equals 0. X-intercept, none. Y-intercept, 0, negative 2. So I'm going to go ahead and plot it at 0, negative 2. And if that's my y-intercept, then my graph has to go like this, because it has to go in that section. And then this one has to mirror it. Okay? But it says there's a hole at x is equal to 3, so I go where x is 3. X is 0, 1, 2, 3. So when x is 3, right up here in the graph, there's got to be a hole in your graph. And you can check any of those ones on Desmos. They will give you the exact same stuff. Okay? So, here we go. Next, identify holes in the graph of this one. Well, I don't know if there's holes until I factor. This is x plus 6 and x plus 2. Bing, bing. There's a hole at x equals negative 2. So this is kind of an easy question compared to this last one. This last one had lots of stuff, but this at least is a way for you to be able to check to see if, hey, I understand what a whole is or where it comes from. Okay, here, number 21. This is solving a rational equation. Now, this could be an x plus 2, and if this was an x plus 2 or an x plus 4 or anything but x minus 3, you simply would cross multiply to solve this equation. I don't need you to solve by cross multiplication. What you can do here is that, just like this, if it was 4 over 7 equals x over 7, then you'd know that 4 has to equal x because the denominators are the same. Here, the denominators are the same, so you can simply write 6x is equal to 4x plus 6, right? Because if the denominators are the same, the numerators have to be equal when the fractions are equal. So I subtract 4x and I get 2x equals 6, x equals 3. Yay, check mark, smiley face, right? Wrong. When I plug 3 back into my original equation, you can see that 3 is an extraneous solution. So make sure you put extraneous on that problem. Okay? This one says perform long division and graph. So what I would do is I'd go x plus 2 into 4x minus 5. And how many times does x go into 4x? Well, that goes 4 times. I take this number and I multiply it to the stuff in front. 4 times x is 4x. 4 times 2 is 8, so I get 4x plus 8. And then I'm supposed to subtract those numbers. So 4x minus 4x is poof, gone. Negative 5 minus 8 is negative 13. Okay, up again, so you guys can see a little bit better. And then this negative 13 is my remainder over my divisor, right? That goes at the bottom of this. And then it went in 4 whole times, so that's plus 4. So my new graph, we can just make this up, h of x, is that. And now this becomes nothing more than this problem that you did over here on this side. Okay? This one, solve this equation. This is a cross multiplication. Those denominators are different, so I'm going to go ahead and cross multiply. I get 5x minus 15 equals negative 7x plus 35. Add my 7x to my other side, add my 7x to my other side, and I get negative 15. And I get a 12x equals 35. I get a 12x equals, when I add 15 to the other side, I get 50. And I divide by 12, and I divide by 12, and I get x equals, as I go in 4 whole times and 1/6 left over, so 4.16 repeating. I feel like that's right. I'm going to check it. I don't want that to be a permanent thing on the video if that's wrong. 50 divided by 12. Oh, look at, yep, 4.16 repeating. Okay, just the 6 is repeating, not the 1, 2. Okay, this last one was a division problem. So again, we copy.plot, and I'm going to factor as we go and see if that helps. Okay, so x squared minus 9 is x plus 3 and x minus 3 over, looks like x plus 3 and x plus 4. Copy, right? And I factored it. Dot, and now I'm going to flop it. Oof. So there's an x minus 3 downstairs. Now the top, I'm going to write this kind of small, 2x squared minus 32, because I'm going to factor it like a dentist, 2 times x squared minus 16. And then I'm going to go, oh, well, that's x plus 4 and x minus 4, that x squared minus 16. Okay? So now I'm going to scratch that out and go, hey, it's really 2 times x plus 4 times x minus 4. Now I can start fighting upstairs, downstairs battles. And you can see I got an x plus 3 and an x plus 3, an x minus 3 and an x minus 3, an x plus 4 and an x minus x plus 4. So it looks like I have a 2 times an x minus 4. So 2 times an x minus 4. Or I could write that as 2x minus 8 if I wanted to. knowing that x cannot equal any of these things that were in my denominator spots. So -3, -4, +3. Okay, and technically, because this was down there too, I could probably put the +4 because that was in my denominator before I copied out flopped it. And again, as long as you're showing me that you know some of this stuff, we should be okay. Okay, what else do we need to know? We should know some basics on some of these equations, but I'm going to do the Cedar Point one. So let's say I have this equation. C is equal to 1500 over P minus 4 plus 65. And this was the Cedar Point trip equation where we needed to rent a bus, and the bus rental was $1,500. We needed to have some chaperones. So this was bus rental. We needed to have some chaperones because you can't just stick a whole bunch of kids on the bus and let them go. School wouldn't allow that. And we need to get a ticket to Cedar Point. And so the two variables in this equation are C, and that C stands for cost per student for the day for those activities, rental bus and ticket price, food, all that stuff. Those are different things. And P, that's the total number of students. Total number of people on the bus, which includes chaperones. That's students plus chaperones. Okay? So if I ask you a question like, well, how much would it cost if 40 people went on the bus? So that 40 is the P, and I'd have to plug it into my equation. So go to your calculator with me, and we're going to do a couple of things in here. So I could do this. I could go to my y equals, and I could actually graph this whole thing. So 1500 divided by parentheses, 1500 divided by parentheses, x, because it doesn't understand a p in here, you have to use x, minus 4, close parentheses, plus 65. Okay? And then if I go to my table setup, that's second in window, I'm going to start it at no students and go up by 1 student. To see my table, I hit second in graph, and you can see it'd be -3, 10. So none of these first things make sense. I can't have 0, 1, 2, 3. I can't even have 4 people on the bus, because 4 people on the bus, since I have to have 4 chaperones, that means that all of them are chaperones and they don't pay anything, which means we wouldn't have anything. So if we had 1 student, it would cost them $1,565. Okay, 5 total people on the bus is 1 student plus 4 chaperones, and $1,565 makes sense. That's $1,500. The kid has to pay the entire bus cost. Very awkward because they're on there with 4 different chaperones, and $65 to get in, $1,565. But you can see the more students that we add, the price goes down. And I said, what if we get all the way up to 40 people? So I can go all the way down here to 40 people, and I find out that the cost per student is $106.67. Now, of course, I didn't have to do it like this with the chart. I could have actually just plugged 40 into the original equation, because that's all this table is doing, is plugging all those things in. So I'm going to go here, second clear. I'm going to do 1,500 divided by parentheses 40 minus 4, close parentheses, plus 65. And you can see that I can get the same 106.66 repeating just by plugging it into the equation. Awesome. So my next question would be, how can I get the cost down to $100? Right now it's at 106.67 for 40 people. Well, if I say cost is $100, that's the C, and that 100 has to go into that portion of it. Well, the easiest way to solve that one, I think, algebraically would be write this equation and solve it for P the same way when we solve for x-intercepts. We move the 65 over, we do cross multiplication, we do all that stuff. Or, for those of you who are starting to get good at these, we go to y equals and we say, well, y is the cost. I'm going to go ahead and put 100 into there. I'm going to get a window that makes sense. So 0 students to, let's say 70 students on the bus, and 0 cost up to $200 in cost, because that's 100 is right in the middle of there. And when I hit graph, there's my cost function, right? Here's my $100. Second trace, number 5, enter, enter, enter. And I can see that I need 46.857 students. 46.857 students. Now, of course, some of you are like, wait, what? That's one odd student. So yes, we would round to 47 students, because that doesn't make sense for the 46.857. Okay? Hopefully that's a great help. The last thing is know a little bit about domain and range. Domain is all the values that X can be. Range is all the values that Y can be, or the outputs. So domain input or the X's, range output or the Y's. And then final thing, I think I'm going to give you a bunch of different equations. Again, this might not be in your year. This is for 2021. But if I give you an equation of a line, of a circle, of an ellipse, of a conic, of parabola, whatever it is, a rational function, that you'd be able to at least name what that function is. Okay? Hopefully this was helpful. Mr. Bell's out. We will talk to you later.